Hello, this is Dr. Hakan Satiroğlu. I'm giving some kind of tutorial here about data analytics by using some Python codes in the real data and some of the example data. Main aim is here is data preparation. Before making any dashboard or business decision or business prediction, you need to set your data accordingly. Therefore, you need to understand how you are going to clean, how you are going to scale, how you are going to check the distribution or correlation and summarize the statistics. So this is the section of the Week. And so it's really important that using some cleaning data set and manage missing values. So this is the first bit. And treat outliers responsibly and scaling features using normalization and standardization. So these are important. You need to check before starting. You need to visualize your data. So data quality is important because sometimes we see that quality is coming from these sections, completeness. Do we have all the values we need? Better, we don't. Maybe sometimes we have some inconsistencies exist, okay? Categories are not aligned with each other. So sometimes we see that values are not making sense according to the context. Sometimes we see that problems and misinterpretation in the data. So yeah, all of them is important and you need to check the systematic way, in organizational way, is the missing points or outliers or normalizations are because correlations are not disrupted by the pattern way or distinctive methods. So blindly deleting or blindly accepting some wrong information could create biases. Therefore, it's important. Let's jump into the handling missing data. Then we are going to follow up with outliers, normalization, and some of the other techniques we will follow as well. So handling missing data in Python is you can use that one. So you can remove simply that data with drop now. So as earlier mentioned, I don't suggest, but you can decide on your own case in your business whether you need to remove or not. But I suggest you to use this function, fill now function, and to replace that data, missing data, with median or mean data. So this code is making that one. So what this code is saying here is defining one of the table 21, 22, none, 24. So to illustrate that one, I made this Excel table. This is the like columns. Or page, and age, and some of them, as you can see, missing here. Okay, some of the scores are not, one of them is missing. So this table is represented by Python in that way. So after that one, so you can remove the dropping with dropna, or maybe you can fill mean data or fill median data imputation. So it's going to print out later on the outcome of this code. Okay. So literally copy paste that note from here. I'm going to minimize that one, because this is my third record. So I made this one earlier. Because first it didn't work, I stopped recording. Then another problem occurred, and I had to stop again. Now this is my third record. Let's see whether it's gonna finish on time without any hassle. Okay, so when you copy, the codes are here. So this is the Colab screen, and you can test your codes is working or not before going any detail base. So you can run. So as you can see, drop now is removing the imputed data, which is first data, and second data is removed, and it means we left with 0 and 0 and, okay, a little bit zoom, I think is too small for you. It remove drop now function, just remove that first and second records. So that one is kind of overriding the problems, and it seems like it's not reasonable. Instead, you can use mean imputation, mean value for that NA 22.33, or you can use the median value for age. As you can see, score section is, the column is filled accordingly as well by these codes. Codes are here. DF fill mean and DF fill median with DF fill now function. Okay, so also you see that on the right, some Gemini is helping us as well. Splash, maybe advanced is going to make better, but I don't need at the moment, but later maybe we may need to use that one. After that one, this is the small introduction to Colab. You click that code to then Colab is expecting you to submit another code. Okay, so okay, let's jump to the next slide. Okay, outliers. Outliers means, as you can see in the middle, there's a line. And your observations, your data should be around these. And you can see some of the potential outliers over there. And you need to detect that one. And the observations far from the rest of the distribution is the outliers. And are the outliers and can reflect rare genuine case measurement errors or data entry problems sometimes. Yeah, I've seen that one a lot. And can strongly affect average, spread regression lines, and model behavior. So therefore, you need to take care of the outliers before submitting your model. Okay, so otherwise your model is going to be disrupted because of you didn't check earlier about outliers as well as missing points. Don't assume every outliers must be removed. Some are exactly the interesting cases. So therefore, it's really important to check whether they are okay or not. I have this new code for you guys. Okay, let me double check because it seems this is not the one. Follow, yeah, thanks, follow that one. But these numbers, it doesn't work. It seems like messy. If it doesn't work, I'm going to ask Gemini to make a correction. Okay. Okay. So as you can see, this data is I put something totally different. Yeah. So before jumping that one, I need to introduce I need to explain quartiles. So maybe I should write here extensive one. Type quartile range. This is missing on the slide. So detecting outliers with the interquartile range is the formulation, and it's dividing. This is like this rule is identify the points that sits unusually far from the central spread, and it's useful. Compare it briefly with the Z score. So, however, you don't need to you don't need to see and you don't need to calculate that one because the program is making for you that Z scores as well, and it focuses on the middle of the 50% of the values and making it less sensitive to extreme outliers. So it means this formulation is taking care of your data and taking 50% in the middle, then removing the right and left, some of the other section like so this is the way it is made. Okay. So let's run that one. I'm not sure it's gonna work because these numbers shouldn't be here. Okay. Seems I need to remove them. Let's try. So as you can see, this is the problems this showing here. Data. This coding is really sensitive. You need to be careful about all these wiggly signs. Okay. Okay, now I zoom in a little bit more. Let's zoom down just for now. It is going to run. Yes, it's running, but it doesn't show anything. Yeah, because I didn't put anything here to show outcome. Okay, just in order, maybe I can add a later on, and you will see that one. And this is the normalization, the next section. Okay, maybe before jumping, maybe I can go and find my notes. Because before that one, I what 19. I didn't save that one down here. Seems okay. And we are here now. One. Okay. Outliers didn't yield any outcome, but it made the compare with Z scores. I'm going to include that one later on. And normalization is about you need to understand that this scale is matters for many algorithms. Distance-based methods, gradients-based methods, and some regularized models can be distorted when features are on very different scales. So these methods are, how you are going to select that one is going to be learned by you later on. This is like normalization is often used when bounded ranges matter, while standardization is common for many modeling workflows. So it is important to check this normalization and standardize normalization as well. So I have another example here. I hope I end up some of the notes. Okay, let's tackle on to slide 22. 2, 4, 6, 8, 56 to 5. Okay, let's round down. No, not here. Let's round that one somewhere. Okay, we don't know why outcome doesn't come. It's running, but it doesn't show any outcome. Okay. see whether it's gonna work. I want it to work. Some suspicion about my plot is working or not. Oops, down. Sorry. Oh. So original data is that one, and min-maximum normalization data is that way. And our studied 0. This is min-max normalized data. This is standardized data with z-score. It is responding to the previous example as well. So min-maximum scaling keeps the shape of the data, but squeezes it into the fixed range, 0 to 1. So what does it mean is a bit difficult to see at the beginning, but when you come to outcome, you can see 0 to 1. However, on the other hand, standardized scaling tells us how far each value is from the mean in the standardized deviation units. So we often use our scale data because some machine learning methods are sensitive to variable being on different scales. So therefore, sometimes we scale or we try to put them into one standardized scaling, mean maximum scaling, to make your model working. Okay, so let's code another one. Okay, I added that one on figure 1. Okay, let's copy the cell because the figure is really helpful. Okay. When you run this report, as you can see, this is the hour studied, exam hours. This is your data, original data, plotting. Then this is the min-maximum run normalized data. So both variables are squeezed into the 0 to 1 range. And standardized data is both variables are centered around 0. It means, can you see in the middle, that's 0. So show how far they are from the mean. So it is important for you in that analysis. So better to make them together and stick them together. It would be nice. Okay. So okay, let's that one. Let's show that one. So this is the idealistic way, or both are like overlapping each other. Scaling data in the Python is the codes are coming here. I have some extra codes here. Probably you will see that one in the notes because it's not there. It's interesting. Just copy one. Let me find the other one because I made 2 right notes. Okay. Let me copy them here as well. The cell. So whoever has got my notes can reach these codes easily. Those are here. stick here, and yeah, you can copy paste them later on for your convenience. Okay, let's get rid of all the extra stuff here, and yeah, let's carry on our new prompt. We are gonna punch the next section from here. If it doesn't here, I'm gonna go and find and copy here as well. Okay, let's follow that one. So this is the mean and maximum and standardized way of showing your data. And as you can see, Penguin data, this is like one of the data I earlier showed here on the slide. This portal is sharing, they share the Penguin data. I'm using example because it's really suitable for the machine learning tools as well. So which I'm planning to show that one at the end of this seminar, and you will learn. So this is the Penguin data, how the minimum normalized Penguin data is shown. So literally okay, let's find that one. It should be somewhere. Oh, better to find that way. So this is the Penguin data. So let's take that one. So I have some notes here. Why I'm teaching this? Because the real data set rarely come in the neat, comparable units. One variable may be in grams, another one is millimeters, another in small decimal ratios. If you analyze them in a raw form, the bigger number variable can dominate simply because of scale. Maximum normalization and standardization help us variable comparable before analysis. So therefore, it is important to normalize them. Okay, you need to check whether their effect is going to be big or not. Okay, let's copy that one here. And okay, let me introduce a little bit on this one. This is again starting with some introduction. These are important, and you don't need to write all of them. You don't need to learn, but you need to import and you need to bring some database and as well as library from the Python and some functions as well. So when you see that upload Penguin CSV, which is Penguin is our data, so it is going to look after the data and ask whether it's going to ask the link in my computer. After that one, it's going to start to use the scale, mean maximum scaler and standard scaler, and show them, plot them in this section. The plot wouldn't work if we don't use this line. So as you can see, each line is given here at the beginning is really valid for the rest of the program, and it is really helpful to learn this system at the moment. Okay, let's run that one. When I run this one, the program is going to ask me to choose file because it doesn't know the data itself. Remember earlier example, we have given Python some data, as you can see, but it doesn't know now at the moment. There is Penguin data. It is asking. Okay, let's choose that one on my file. Database, Penguin data. As you can see, this is the normal system. As you can see, Kuhlmann length and body mass is two different. Okay, you may wonder what does it mean. Okay, so this is the Kuhlmann length. Okay. coming that reach along the top part of the bird's bill. So this part is a bit, yeah. Okay. So as you can see, if your model is linked to these two variables, so when you are running your model, is it that the orange one is going to dominate your model. However, if you need to check whether this is genuine or not, I mean maximum normalization as well as standardized penguin data set. Okay, so it seems it's reasonable at the moment. I'm displaying this because many analytical methods become misleading when variables are measured very different scales. You could see the real data, and its graph is dominated with large values here. As you can see, the body mass is the weight is really high. Others doesn't see. Okay, even Kuhlmann is smaller here. Okay, if you include that like weight of the penguin. Okay, so this is the part of that standardization. You need to double check that one. So what is exploratory data analysis? So it's like examining data visually is important and statistically before formal modeling. So finding patterns and anomalies and distributions and relationships are here. Okay, you are going to find them here. How you are going to find them? Here is you are going to use this histogram and distributions as well as some box plots. Can you see outliers are here, as well as some correlation matrix. Okay, correlation analysis. You are going to do, and you are going to learn now. And I'm going to share this codes with you as well, Python codes. Yes. So this is histogram, and as you can see, we always want to see our data is normal distributed. What does it mean normal distributed? Is a bit challenging sometimes, but easy to explain by showing this kind of graph. So like, let's say your data is coming here and expected to increase, later on picked up, and later on it's going to be down. So this is normal distribution. Sometimes we see that normal distribution is really skewed. Sometimes we see that the normal distribution is you need to understand your data, how it is working. Sometimes we see that normal distributions are just nothing happen later on the site. I think the last one didn't work. Okay, let's put that one the other way around. Okay, now it works better. So as you can see, that skew is on the right. Like we call that one is skewness, and the other one is kurtosis. So yeah, but I mentioned them here. So you need to check whether symmetric is okay or not. You need to aware before proposing, and also you can show and you can report your data accordingly. Okay. Okay, this is given here. Your model as well exists. Okay, left skewed and right skewed. Yeah, these are the checkpoints you need to check. You need to follow up. Let's check that one, whether it's working or not. Yes, this is the data, 12, 14, 15. So as you can see, 15 is repeated twice. It means 15 is going to be a bit like 2. And yeah, like this is generating that way, and this is simply like you are gonna see your data by using only the simple codes by importing like plot pilot from PLT. Okay, let's make that one is a bit harsh, difficult with Penguin database. Okay. Before going that one, we can adjust this sequence like 11 to 13, 13 to 15, 14. So this is the section is given here on the right. Can you see that bins? If I put that on 5, it's gonna make 5 for interval sections. Okay, so here is interval is 2 at the moment. Automatically checked by 2, but it's 5 actually. Yeah, it seems. Okay, let's carry on the next one. Choose the file. Always it's gonna ask that one, Penguin data set. It doesn't report. As you can, that has got RAM and disk here. And as you can see, 3000. So you can change some codes are here, like you see oranges are here. Is that black? Or maybe you can change that one. Okay, then mention that one, isn't it? So let's make that one 100. Then you are going to see really big. Yeah, as you can see, it's dividing bigger picture. So if you want it really smaller, so that simple, that code is working to show histogram intervals. See, it's a big rectangle. Okay, so literally it is not dividing to anything, any section, but you need to find that one is idealistic way. The best fit, best presenting is always up. Okay, this is the one. Body mass, it is not bad. That one is not bad, and I present that one on the right. So I show you some adjustment on the codes as well here. Yeah. Literally, you can copy that one into your LLM model, and it can generate for your own data, your own analysis. And okay, let's go to next slide now. This is the box plot. We set it quartile interval, so we mentioned that one. So something is outer. This is the section actually. It's the presentation of the interquartile Q1 and Q3. So box plots summarize median quartiles, spread, and potential outliers. They are compact and especially useful for comparing groups. So this is really important to check before running anything. Okay, let's run that one. Now. As you can see, one observation is out of the scope 40. So it is taking, like, as I've been said, 50% of observation here somewhere, and it is making that box around it, and something is really outer that 50% is taken out here. It's presented. So you don't need to know any technical point because it is done by the job is done by this box plot data, and yeah, that's it. So we can present that one with penguin analysis. One more time. I need to use this notepad because somehow that the best doesn't work from PowerPoint. It is asking where is the data. Data is here. So box plot is okay. Nothing is wrong here. Okay. So body mass is working fine. Okay, let's manipulate that one. What else? Save this, but I don't want to use the data later on. We don't need this one. And now let's rerun, same plot. And it's going to ask, yeah, this is the manipulated data. As you can see, so plot is really small because I made them 10,000 kilogram. So this should be kind of typo error. So as you can see, box plot is showing some anomalies, outliers are there, and you need to check whether what's the problem. Sometimes we see that outliers is interesting to explore. So yeah. So correlation matrix, okay, the next section is the correlation matrix is like correlation measures or the strength and direction of the relationship between two variables. So please don't forget, this is not like giving us any idea about two variables, relationship between two variables. I mean, regression or causal effect of the two variables. It is causative analysis. It is not like correlation is totally different. Okay, so negative correlation and positive correlation can happen as well. So they are not linear correlation. Okay, so something is really totally different, or it means they are not going to create a linear correlation. So now we are going to move a little bit like about this correlation types or regression types. And correlation doesn't imply causation. Two variables may move together because a third variable or because of the coincidence. So this is really important. You need to double check. You need to be really careful about offering that is causation. It means like people are putting their hand in their pocket. You can say they are rich. Who knows? Maybe they are cold. Okay, so this is like you can say you need to propose something is interesting. Like we call that one is you need to work rigorous preparation before proposition that causations. So correlation is not enough for that one, but it's useful to identify potential meaning and relationship, supporting redundancy among features. So this is like important, and so this table is like students studied hours of studied, and their exam scores is meant to be correlated with positive way, as you can see. What does it mean, positive way? So we say here in the math screen, like X and Y, remember that one? Somewhat. So we always say if the line has got this, it means from X to here, it means positive. If that graph, okay, let's make another one, next one. If that graph specifically going other way around, I don't know where is my mouse. Huh? Yeah, there we go. It means the angle is here, so it means it's negative. So as you can see, the graph is in correlation is positive. Okay. So if the correlation dots were that way, let's put. So in that sense, putting them together means other way around, it's negative. Okay. So this is the correlation mentality. Sometimes that correlation doesn't come as a positive or negative. It is kind of like no linear correlation. So nothing is you can say. Okay. Then it's so what is the code? Python codes are here is given for us. When you are looking, when you are checking some academic papers, you can say that heat matrix. Okay, so I'm going to use that one similar way, but now let's put that one here in first. So correlation matrix are given here 1, 99, 99. So as we can see, these two is same because this is the hours of study and attendance. Hours of studies, attendance, exam scores are coming here like a cross section. So it means I can make that here as a visible for you. These two should be same things because attendance and attendance and hours exams, our studies, attendance and our studies. Intersection, okay? Intersection. And these two always same. And these two should be same as well in the correlation matrix. And the other one is the one in the diagonal should be always one because they are literally same things. Attendance correlate with attendance should be one. Okay, if it is not one, there should be some problem here. Okay, let's make that one with a little bit like extensive example with our penguin data. Yeah, just need to select them. So it's generated because it's not fitting in a row because it's too big and too long. So therefore, it is making in a different way. Penguin, Kuhlmann depth, Flipper length, body mass, delta 30. The all data is checked. Okay, I checked. I included all of the the variables in the table. I included them here, and I put here as a screenshot. But as it is big, too long, it's not fitting in the one space. Okay, let's put them into that heating map because this is the main thing is many papers, academic papers are made or presenting that way. When I run that one, it's asking again that penguin data. As you can see, these blues and yellows is 1 because should be diagonal. When you see that the really big so negative correlations are here on the blue and green. So when you come here 0 is up to the blue, yellow to green as well as blues are 0, near to 0. It means something here is 0, something that one is 0, Kuhlmann length, and delta 13 and delta 15 is they don't have any connection, but however they have each other around 50% correlations. So some negative correlations are exist here as well. So this is a way heat map we are using in academic papers as well to show the importance correlation between them. So delta 15 and delta 13 is not related with these any of them, but I included them as a random to show you here. Okay. Maybe we can remove them here, but I don't want to change anything. Just I want to proceed next slide. So measures of central tendency is like mean uses all values and is sensitive to outliers, if you think, and this is like a recap for you. And median is the middle value and is more robust. Mode is the most frequent value or category, you can say. Sometimes, as you can see in the table, medians could be here, but means are here and modes are here. And you need to learn about them as well. I presume you know about those, but just I made some of the small code for you. Run and check whether your means and codes are for each column. You need to make that one for each column. So median and modes are reported by. So okay. So for this table, it is, let's make that one is 14, 200. Let's run them. So mode is 14 because 14 is the most repeated one. However, it doesn't say anything about our data distribution. So therefore, you need to check the normality, skewness, and other stuff. Here is given only median, mean, and mode. You need to always careful about them. So 14 is the median, it seems. So mean is affected by this high value. Therefore, 200. It's just skew that your data, it seems like 434, but actually it is not. It is just your normal data around here. So mean sometimes might disturb your interpretation. So also we have other measures to check your distribution, your data is okay or not. So variance and standard deviation. So two data sets can share the same mean, but have a very different variability. So variability in standard deviation or variance is almost same things, just sub-square is the variance, it means standard deviation. Is the center of the distribution is only part of the story. Dispersion tell us how tightly. So it means when you are checking that means, mean, median, modes, it's not helpful. You always need to check standard deviation and variances. So I made the codes are here as well. Okay, let's put them down here and run the same report. Oh, because it doesn't fit for my PowerPoint slides. So variance and standard deviation is too much. Let's remove that one, 200. So it is normal now. It's becoming good. So it means if you have a too big disturbance in your data, your variance is going to come with pretty big number. So this is another check before going to deep inside to your modeling and other stuff. Okay, let's carry on the next down. So what we have here is real analysis we made So all of them are step by step. You can randomly check, all of them, and with this way, if you don't check missing outliers or histogram scaling or correlation, you are not gonna get like idea about your data. At first, you need to understand your data, and they are not isolated steps. They are interconnected, and you need to understand them, and you need to follow these each for each column. So in your data, you need to check. Okay, maybe you can strategically select. Some of them you can overlook, but mainly you need to check all of them. And here is the key learning. And so one of the thing is handling missing data. Other one is identifying the treating outliers and normalize standardized features, explore distribution, and measure correlation, and compute core statistics. Okay, for this one, we made that one, but yeah, I think I'm gonna add another point. Okay, I'll take that one note. Maybe on the next hour we can have a look. So Week 3 is going to be a statistical modeling and machine learning. So I think I will go another week for this one as well. For this data analytics, maybe 5th or 6th week. I was planning 3 or 4 weeks, but it seems a bit longer. So before going more, I just want to show you because what we do is about dashboard, and we try to make these analysis like make it something outcome for your convenience. Okay. So what I did is I made 2 practice with you, because it seems currently these LLM models are making this kind of stuff for us. So I come here. Data was here, the Penguin data. I ask Copilot to make so I ask, please make the dashboard for me. Then maybe I'm using totally wrong one, but this is Copilot made this kind of dashboard for me, but I didn't dive too detailed. Then I come to the cloud, and that cloud is has made like I put data set, and I put here data sets design, KPI charts. So it made this kind of graph or dashboard for us. And imagine we check all the outliers, missing data and other stuff. Then we follow up with this data. Then, as you can see, all data is here and is presented pretty nicely. Okay, let's check. This is the Torgersen and Visco and Dream. These are the islands. Okay, if you check the islands island-wide, Flipperland, as you can see, it's here given. If you check the Visco, it's a bit distributed. It seems a lot of migration comes from different areas. And the Dream is a bit circulated area as well. It's on like normally it is a bit skewed on the left, but Torgersen is a bit like a lot better. Even we can improve that, remember that sections we can improve, and we can check whether that skewness is or Curtis is becoming hectic or not. Also, you can check in terms of gender, penguins. Land is here. Where's the body mass? Okay, it's just that one is made a bit like crazy because it's reported same. It should be updated. It doesn't update, but it's updating data itself when I check that one here. So as you can see that the versus Kuhlman length And body mass ratio is kind of like is bigger for the male. However, this is come to left, yeah, on the females. Okay, so even data is could be checked by observed, which is okay. Some outliers are here, should be checked probably, but it seems it's okay for now. So as you can see, generative AI making this kind of reports for us as well. Also, I would like to introduce and I would like to make another video for this application, another application. Okay, let's find out. Click. Click is one of the dashboards, professional dashboard, and it's given free 1 month free. You can trial. You can have a trial application. When you log in, something wrong. Yes, I'm hoping I'm in there now. Some of the examples are here as a dashboard. You can find cases. Some of the training and library tools are available here, but just this is not what I wanted to show you. I wanted to share with you more. Let me find that one or up. It's making. Somehow it worked again. So this is the cloud version. I'm using it from the application, not downloaded anything. So the applications and machine learning experiment, automations, data connection, data flow, really extensive knowledge here. It's waiting for the exploration. And some of the examples are here in application. As you can see, I installed. Yeah, here we go. So this is the open beginner application. It says it was on the internet. I downloaded and I uploaded. I downloaded in my computer and it worked that way. So as you can see, this is the some of the sales, and if you click edit. The organization has got different regions, Germany, Japan, Nordic, Spain, UK, and United States. And their sales figures are here. Also, you can see some regional distribution. And as you can see, this is like, the similar way, it is similar mentality, it is done by LLM. But this is specifically, this quick application is specifically working on this one and also some extra stuff over there. And it's worth to know. Also, I can say Power BI, Tableau, and other alternatives are exist as well, but they don't offer us this free trial. Therefore, I don't have the chance with you to show them. So yeah, so this is the one. The first, maybe you can say this is not enough, but it is not including only that one. On the right top, if you search, if you navigate, right, as you can see, you can add as many as report you want. Okay. So please don't assume it is simple and it is not like something is special. It's a special program, and like some of the other sections. And as you can see, eggs, sometimes, the eggs are written by your employee as an egg. You can see that classification as a second one. So in your filtering and data, when you are before preparing this kind of report, you need to adjust all your categories or any mistypos accordingly. So let's work on this one a little bit more. So you can search in terms of like years. If you click 2014, as you can see, it's automatically changing everything. And you can even check, the more than 1 year, then it's gonna make the job for you. Then you can only focus on for the quarter one, and it's gonna report. Also, you can check whether any specific region or two region is working or not. As soon as you pick them, it's automatically picking that one back here. So you might have interested in how to make this kind of graph. So this is the data it is given here, but original data, I don't have the original data. This is like what I downloaded is just the ready-made report. I can work on this one by editing, so I can work and I can improve, and yeah, you can improve as well your way of working. When you click right, then data is here. So what you can do, you can add maybe cost. Okay, add the cost. You can make some average count. And it's gonna work in that way. You can change some quantity, margin, as you can see, it's automatically changing on the right percentage. Quantity as much as I put up here is fitting up here, you see. And it is better to have some specific one rather than all of them in here. Okay, just I'm gonna undo. I don't want to mess up because it's too much here. Okay, just margin is okay. And I think that one is wrongly made. So dimension is customer. Maybe you can change that dimension as for it's another one. Customer sales and quantity. Quantity. So I would like to make some kind of a small tutorial for this one as well. So this is the click application. I'm still investigating on it, and yeah. Thank you very much for listening. So please feel free to make a comment, the chat thread underneath, and take care. Bye bye.